Good evening, friends. Today we are going to discuss here the course name Discrete Mathematical Structure. So basically, the discrete mathematical structure which containing total 6 units, and out of that 6 unit, as per the importance of the examination, according to me, I am going to discuss here the important points for the unit number 1, that is the mathematical logic. So basically, in the mathematical logic, the very first point is statements and notation. So before going to statement and notation, what is meant by statement? So statement is nothing but, it is also called as a preposition, or it is also called as a declarative sentence. Okay. So what is meant by preposition, or what is meant by declarative sentence? The declarative sentence which having truth value either true or false, but it does not having truth value true and false at a time. So that is called as a statement or declarative sentence, or it is also called as a preposition. Okay. So every statement is a sentence, but every sentence is a not statement. And basically it is represented by using truth values either true or false, and logical values 0 and 1. So these are the two notations which is used to represent the statement values. So talking about types of statement, statements are classified into two types. You can see here, the first one is the atomic statement, or it is also called as a primary or primitive statement, and second one is called as a secondary statement. First of all, see here what is meant by primary statement. So primary statement or atomic statement is a statement which is further not broken into the simple statement. It cannot be further broken down into the simple statement, that is called as a atomic statement. For example, today is a Monday. So today is a Monday, it cannot be further broken into more than one statement. So that's why today's Monday is the atomic statement, or it is also called as a primary statement. Fine. So today is a Monday. So today itself is a Monday, that's why the truth value will be true. And on tomorrow, it will be truth value false. Means for the current moment, it having the truth value as a true. That's why today is a Monday is called as a statement. Fine. Then Canada is a big city. So what you can say, Canada is a big city, or Canada is a old country. So in the some part of the world, it may be true, or in the some part of the in the other part of the world, it may be false. So that's why it is confused that Canada is a big country, true or false. So that's why it is called as a sentence. It is not a statement. Fine. Then one more example, Mumbai is the capital of Maharashtra. Yes, absolutely, Mumbai is the capital of Maharashtra. In universal, whenever you will be go, it will be true. Fine. So that is the difference between statement and sentence. Now talking about the notations, as I mentioned earlier, so these are the two notations. You can see truth value true or false, and binary values 1 or 0. So that is the notation for representing the truth values. Fine. Now one more, primitive or primary statement or atomic statement, which is denoted by uppercase alphabets A to Z, or generally it may be also represented in lowercase alphabet also, but mandatorily you have to put in uppercase alphabet. And second one is the secondary statement, as I mentioned earlier. So secondary statement which containing some connectives, that's why it is called as a secondary statement. So in the case of secondary statement, 5 types of connectives. So basically unary connective and secondary connective, unary connective and binary connectives are there. So in the case of unary connective, which is going to perform on the single statement, that is called as a negation. And in the case of binary, we having conjunction, disjunction, conditional and biconditional. So out of this 5, if any statement, if any connective is used, then it is called as a secondary statement. Fine. So as I mentioned earlier, Canada is a country. Yes, it is a true. Then second one, Mumbai is the capital of India. No, it's not true. That's why it is a false. So these are the two statements. Fine. Then connectives. So basically, as I mentioned here, the connectives are classified into two basic type. Keep in mind two basic type. First one is the unary and second one is the binary. In the case of unary, you can see here, in the case of unary, if you see, negation is the unary. Negation is the unary because it is going to perform on a single statement. And talking about other, all these other, conjunction, disjunction, conditional, biconditional, all these are binary connective, because for these connectives we require at least two statements. So one by one we are going to discuss in here. So first one is, so already we have discussed this, what is meant by primary or what is meant by compound or secondary statement. So that is the atomic or primary statement. The statement does not contain any connective is called as a primary or atomic statement. Then second one is the molecular or compound statement or secondary statement. The statement which containing number of primary statement is called as a molecular or compound statement. Okay. Now see here the first one, negation. So as I mentioned earlier, negation is nothing but the unary connective. Negation is nothing but the unary connective. And whenever in the given statement, if we connect not, then the given statement becomes a negation of the original statement. For example, P is the original statement, then negation of P is written as negation P, and it is read as not P. Fine. Now, simple example which containing P is the given statement and which is London is a city. London is a city. Then as we know that London is a city, yes, it having truth value true. Fine. And whenever you will be going for negation of P, it will gives you London is not a city. It will gives you truth value as a false. Fine. So in the truth table construction method, if there is a single statement P is there, then number of rows will be 2 raised to n, that is 2 raised to 1. It will gives the first value as a true, second value as a false. And alternatively, negation of P which gives you false and true, because true's negation is false and false negation is true. Okay. You can see here, this is the symbol used for negation. This is also symbol for negation, or we can use a bar or we can use a not also. Okay. Means negation P, bar P, not P. So these are having same meaning. Means if P is the original statement and it having truth value or logical value 1, 0, then it will be having output as a P, it having the negation as a P bar, and which gives you 0, 1. Fine. So that is the gate symbol for the negation. You can see here P is the input, then here is the negation, and here is the P bar. The next one, second type of connective, that is a conjunction. So the conjunction is nothing but called as an ending of two statements. You can see here the conjunction of P and Q is a P and Q, which is read as P and Q. The statement P and Q has truth value true when both the P and Q having truth value true. Otherwise, it having truth value as a false. Okay. So what is the important thing is here? If both the truth values of given statement P and Q are true, then it is a true, otherwise it is a false. For example, we are taking here two statements. The first one is P is what? It is raining today, and second one is Q is there are 20 tables in room. Then you can write this as a it is raining today and there are 20 tables in room. Means basically P and Q are combined together here. using conjunction. And as I mentioned earlier, as it containing two statements P and Q, as it containing two statements P and Q, so number of possible rows with respect to the truth values will be equals to 1. That is first one, second one, third one and fourth one. Okay, so true true, false false and true false, true false. And finally, when both P and Q, having truth value, you can see here, when both P and Q having truth value as a true, then it is a true. Otherwise, you can see here, whenever alternative values are there or whenever both the values are false, you can see whenever both the values are false or alternative values are there, then it is a false, because it is nothing but the ending. Keep in mind, you have to draw this table also. Then next one, this is the AND gate. This is the first input P, second input Q. This is the AND gate, fine, AND gate, and we have the result P and Q. That is the logic gate for the conjunction. Now talking about conjunction, conjunction which follows both associative and commutative law. So what is the meaning of associative and commutative law? Means what? P and Q. P is the first statement, Q is the another statement. We can perform P and Q. Also we can perform Q and P, and both having the same result. This is nothing but the commutative property. And talking about associative property, consider A, B, C, these are the two statements. A, B, C, these are the three statements. Then A and in bracket B and C, which is equals to in bracket A and B and C. That is nothing but the associative property. Means what? Conjunction follows both associative and commutative law. Keep in mind. Fine. Conjunction is also denoted by this, you can see here, and it is also denoted by a single dot, and it is also denoted by ending. Fine. So that is the conjunction. Then next one, negation. Then next one is the disjunction. Disjunction is nothing but the ORing. So in the case of ORing, if P and Q, these are the two statements, then ORing of P and Q, which is denoted by P or Q, that is the symbol for ORing, and it is read as P or Q. The statement P or Q has truth values false. Please listen carefully. The statement P and Q having truth value false only when both P and Q having truth value false, otherwise it is a true. So as I mentioned earlier, it containing two statements P and Q, so definitely 4 rows will be there, 1, 2, 3, 4. That's why it is combination true true, true false, then false true and false false. That's why it containing 1, 2, 3, 4 values. 4 rows are there. If there are P, Q, R as a 3 statements, then it will be containing 2 raised to n, that is 2 raised to number of statements, which is equals to possible number of rows in the given truth table. So whenever both the values are true, then it is a true. When alternative values are there, again it is a true. And whenever both the values are false, then it is a false. That is the important, or that is the key point. In the case of disjunction, you can see here, in the case of negation, in the case of disjunction, whenever both the values are false, then the resultant of disjunction is also a false, otherwise it is a true. Please keep in mind. Then next one, disjunction, which is also classified into two types. First one is the exclusive OR, and second one is the inclusive OR. So what is the meaning of exclusive and inclusive OR? So basically whatever we are discussing, that is the inclusive OR, because exclusive OR, it is nothing but the special type of the connective which will be discussed under NAND, NOR and exclusive OR. So for this current discussion, you have to keep in mind, this is nothing but the inclusive OR. Means whenever we are discussing disjunction, you have to keep in mind it is nothing but the OR. So in the case of inclusive OR, this will be the same result. This is the result for inclusive OR. And in the case of exclusive OR, if alternative values are there. Means for example, if P and Q, these are the two statements. If P having truth value as a true, Q having truth value as a false, then the result is true. Fine. Or if P having truth value as a false, Q having truth value as a true, then the result is true. Whenever both the P and Q having same truth values, either true or false, then it is a false. Okay, so that is the concept of exclusive OR. Meaning of exclusive OR means what? In given two statements, it should be performed the ORing operation exclusively rather than inclusive. Because previously you can see here true, true. Both the values are true. So that's why you can see here is the true, and this spoils that rule of exclusive OR. That's why it is an inclusive OR. As it is present over here, it is nothing but the inclusive OR. If this result is false, then it is an exclusive OR. So that is the logical gate for inclusive OR. You can see here, P is the first statement formula, Q is the another statement formula. That is the logical gate for inclusive or you can say disjunction, and that is the result, P or Q. These are the symbols or this cup notation. Okay. In the case of conjunction, we are using cap notation. Here we are using the cup notation. It is looking like cup, na? Then conditional statement. One more thing I have missed to tell you. Disjunction which follows both associative and commutative law. Keep in mind. Disjunction which follows both associative and commutative law. Then the next one, third one is the conditional statement, which is also called as a if-then statement. Which is also called as a if-then statement. For example, if P and Q, these are the two statements. If P and Q, these are the two statements, then P is called as a antecedent and Q is called as a consequence. Keep in mind, P is called as a antecedent. That is the first statement is called as a antecedent and second statement is called as a consequence. Fine. So, in this case, it is read as if P, then Q. If P is an antecedent and Q is a consequences, then it is read as if P, then Q. And this P conditional Q is called as a conditional statement. P conditional Q is called as a conditional statement. As I mentioned earlier, P is called as an antecedent and Q is called as a consequence. So what is the concept over here? See, as I mentioned, truth values in the given truth table. If both antecedent, once again I am saying here, if both antecedent and consequence are true, then it is a true. Fine. If antecedent is true, consequence is false, then it is a false. If antecedent is false, consequence is true, then it is a true. And the last one, if both antecedent and consequence are false, then in some cases it may be in all cases it is a true. For example, let us consider P is the one statement, I am study hard. P is the one statement, I have study hard. I had study hard. And second one is I got pass in examination. That is Q is I got pass in examination. Means in the first scenario, if I get study hard, then definitely I'll be passing the examination. That is, both the statements are true, then it will be gives you true. Second scenario is what? If I study hard, I will be failed. So it is not acceptable. So that's why its conclusion is false. Third one, if I fail to study hard, in some circumstances, may I will be passed. That is false, true, true. And the last one, if I am not study hard, definitely I will be failed. So that truth table which containing the truth table for conditional statement. And keep in mind that conditional statement does not follow associative and commutative law. It does not follow associative and commutative law. So for that purpose, we having one law which is called as a contrapositive law. For example, listen me carefully. If P and Q, these are the two statements, then P conditional Q is nothing but the conditional. Fine. In the previous cases, that is conjunction and disjunction, which was following the associative law and commutative law, but here it does not follow the associative and commutative law. So for the commutative law, we are using here contrapositive property. For example, P conditional Q, which is same as negation Q conditional negation P. So that is nothing but the contrapositive property. Fine. And one more thing is what? Inverse property and converse property. So what is meant by converse property? If P conditional Q is there, then Q conditional P is called as a converse. And if P conditional Q is there, then negation P conditional negation Q is called as a inverse of the original statement formula P conditional Q. Fine. So original statement formula and contrapositive formula both are same. Then inverse of the original statement formula and converse of the original statement formula, again they are same. So always keep in mind that conditional statement or if then statement does not follows associative law and commutative law. Fine. Then next one, biconditional. See, if P and Q, these are the two statements. Again I am saying here, if P and Q, these are the two statements, then biconditional is represented as, you can see here, P, this is the upgoing arrow and this is the upgoing arrow and this is the arrow towards the P, which is read as P if and only if Q. I have missed to write Q over here. Here should be Q. So it is read as P if and only if Q. It is read as P if Q, called conditional statement. If the truth values of both P and Q are true or false, then it is a true, otherwise it is a false. You can see here. Here P and Q, these are the four possible roles. If both P and Q having same value, either true or false, then it is a true, otherwise it is a false. So keep in mind this one. Fine. Then next one, next point I am going to discuss here, well-formed formulas. So what is meant by well-formed formulas? So you can see here, the well-formed formulas are statements although called as a well-formed formulas. Well-formed formulas are not statements, sorry. Well-formed formulas are not statement although called as a well-formed formulas. Now see here. So basically when the given statement formula or given statement formulas are said to be well-formed formulas. For example, a statement variable standing alone is called as a well-formed formula. For example, P is the given statement formula, then that itself P is called as a well-formed formula. Then next one, if P is the given statement formula, then negation of P is also called as a well-formed formula. You can see here, if A is the well-formed formula, then negation of A is also well-formed formula. So these are the rules. Rule number one is what? The given statement is alone called as a well-formed formula. If P is the given statement, then negation of P is the well-formed formula. Then next one, if A and B, these are the two statement formulas, then A and B, A or B, A conditional B and A biconditional B are also called as a well-formed formulas. Okay. So if you observing these four rules, so what that containing? The first one is given statement. The second one is which having the unary operation as a negation, then it is a statement formula. Then the third one is what? Binary operation, that is a conjunction, disjunction, conditional and biconditional, that is the well-formed formula. And the last rule is what? Combination of all these above three rules or maybe the sum of the rules. Then it is called as a well-formed formulas. So these are the four formulas you have to keep in mind. According to the definition, following are the well-formed formulas. So see one by one, and which one is not well-formed formula. See, negation of P and Q, yes, well-formed formula. Okay. Then negation of P or Q, in bracket P conditional P or Q bracket complete. You can see here opening bracket and closing bracket, again opening and closing, two openings are there, two closing are there. Okay, again this is also well formed, means all these are well formed formulas. These are the well formed formulas. And which one are not well formed formulas? You can see here negation P and Q. When this will become well formed formula, whenever we are adding parenthesis over here, you can simply see here, because what to do in this case, either we have to perform negation first time or we have to perform P and Q first time. That is the confusion. So that's why you can see here, see what is the confusion over here. Either we have to perform negation P then AND with Q, or either we have to perform P and Q and then take the negation. So that's why what you have to do, you have to add bracket over here. So what it will be clear cut? It will be clear cuts that you have to take here negation P and take the ending with Q. That is the clear cut idea about here. And in this case, you have to take ending of P and Q and then take the negation. So that is the thing with respect to the well formed formulae. Yes. Then P conditional Q, conditional in bracket and Q. So what is the meaning of this and Q? It is a baseless. So that's why it is not a well formed formula. Again in bracket P conditional Q. So here is the one opening parenthesis and one parenthesis is missing. Hence it is not a well formed formula. Then next one you can see here in bracket P and Q bracket complete, it's okay. Conditional Q bracket complete. But what is about that last additional bracket? Either you have to remove that bracket or you have to insert bracket over here. So that's why number of opening brackets or number of opening parentheses will be equals to number of closing parentheses. Okay, so these are the some well formed formulas and these are not well formed formulas. So you have to prepare for this one also. Earlier what we have discussed, what is meant by preposition, then types of connectives. So basically two types of connectives. First one is the unary connective and second one is the binary connective. In the case of unary connective, there is only one, that is a negation, and in the case of binary, there are four. First one is the conjunction, disjunction, conditional, and biconditional. Keep in mind. Then we have see what is meant by well-formed formulae. In the case of well-formed formulas, there are four rules. First one is the alone given statement formula is a well-formed formula. Second one is negation of the given statement formula is a well-formed formula. If P and Q, these are the two statement formulas, then P and Q, P or Q, P conditional Q and P biconditional Q are also well-formed formulas. And the last one is what? Combination of all above or some of the above is also called as a well-formed formulas. And on the screen you can see some of the examples which are well-formed and which are not well-formed formulas. Means if question is there, if asked in the university examination, you have to write likewise. Fine. Then duality law. So you can see here duality law. The connectives. So with respect to the duality, we are deals with the only three connectives. This one is the ending. Then we are going to deal with ORing and negation. We are not think about conditional and biconditional connectives. So two formulas A and B said to be duals of each other if either one or one can be obtained by other from the other by replacing and by or by and. Okay, so that is the basic rule. What we are going to do in the case of duality law, we deals with the only three connectives. So what are the three connectives? Conjunction, disjunction, negation, and we are considering here two truth values, true and false. Fine. So whenever we are going to convert the given statement formula into the duals of that given statement formula, simply what we are going to do, we are going to replace conjunction by disjunction, disjunction by conjunction, negation will be as it is, truth value, if truth value true is there, then you have to replace it by false, if truth value false is there, then you have to replace it by true. So by doing all these activities, you will be get the dual of the original statement formula. So if you see, here A is the given statement formula. You can see here A is equals to P or Q bracket completes and R. So which is replaced as, you can see here, instead of this or we have replaced by and instead of this and we are replaced by or. Remaining things are as it is. So this A and A star, this A and A star are called as a duals of each other. Keep in mind this. Then next one, P and Q are true. We have to find out the dual of this one. So what we have to what we have did, this P remain as it is, this Q remain as it is, this AND is replaced by this OR, and this truth value replaced by this false, truth value true is replaced by false, and this OR is replaced by this AND. So that is the thing with respect to the duality law. The next one is duality theorem. You can see here, let A and A star be the dual forms, means already we have find out A and A star as the dual forms, and P1, P2, Pn, these are the all atomic variables occur in A and A star. It may be write as, so simply what we have written here, A of P1, P2 up to Pn, A star is equals to P1, P2 up to Pn. By the De Morgan's law, you can see P and Q, which is equals to negation of negation P or negation Q. And one more thing is P or Q, which is equals to negation of negation P and negation Q. Now we have to show that A is equivalent to A star. Okay. So negation of A in bracket P1, P2 up to Pn, which is equals to A star in bracket negation of P1, negation of P2, and so on up to negation of Pn. So A of, you can see here, A of negation of P1, comma, negation of P2 up to negation of Pn, which is equals to negation of A star in bracket by using simply De Morgan's law, P1, P2 up to Pn. From the equation 1 and 2, you can say A is equals to A star. Simply some substitutions are there. You have to keep in mind that substitution has to be take place over here. So that is the duality theorem. This one is the duality law. Okay, and this is the duality theorem. Keep in mind. Then next one, next point is implication formulas, or it is also called as a tautological implication. So when for example, you can see here, you have given one statement formula P. This is the notation for tautological implication, Q conditional P, and you have to show that P tautologically implies Q conditional P. So what to do for this purpose? Simply as it containing the given statement formula which containing two statements P and Q, fine. So you have to construct here truth table for PQ with four values: true, 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 false, false, true, and false, false. Now you have to find out the LHS. So what is the LHS here? P. So as it is, you have to write down here values of P. Now you have to find out the RHS. So what is the RHS? Q conditional P. Q conditional P, you can see here. So Q conditional P, in this case, this one is nothing but your antecedent, and this one will become your consequences. So you have to mapping from Q to P. So Q to P, whenever you are mapping true, true, it will be true, false, true, 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 false, false, and false, false, true. So that is your RHS. And then what to do? Already we got here LHS, we have here RHS, and as we have to find out here implications. What you have to do? You have to check here LHS conditional RHS. LHS conditional RHS, and you have to check what it gives. So if you go for LHS conditional RHS, then it will gives you true, true as a true, true, false, true, false, false, true, and false, true, which is equals to true. Means what? Whenever you are performing LHS conditional RHS, all the values became a true. So that's why it is called as a tautologically implies. Hence it is a tautologically implied. You can see here, and it is written as P tautologically implies Q conditional P. It is written as read as P tautologically implies Q conditional P. So that is the first one, first example. Then second example, you can see here P and Q tautologically implies Q conditional P conditional Q. You have to show this one. So again, I have taken the statements whatever given, that is a PQ. I have drawn this truth table with these four possible values. Then I have find out the LHS, that is a P and Q. So P and Q will be what? Ending means true, false, false, false. Fine. Then next one, you can go for the RHS. In the case of RHS, P conditional Q. So it is mapping from P to Q. P is called as antecedent, Q is called as a consequence. True, true, it is a true. True, false, it is a false. False, true, it is a true. And false, false, it is a true. Now we got here LHS. This one is your LHS. Okay. So this one is your LHS and this one is your RHS. This one is your RHS. So you have to find out the conditional property between LHS and RHS. So LHS, conditional, RHS. So you can write here true, 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 false, false, true, again false, true, true, and false, true, true. So all the resultant values are true. So that's why you can say that this is a tautologically implies. Okay, so this is a tautologically implied, and it is read as P and Q tautologically implies P conditional Q. This, keep in mind, this is nothing but the tautological implication. This is not a symbol of conditional statement. This is tautological implication. Fine. Then one more example with respect to the tautological implication. You can see this is example which containing three statement variables. Three statement variables are there. That is a P, Q, and R are there. Okay. So what is the LHS over here? P conditional in bracket, Q conditional R. All the brackets are balanced over here. Then we have to check either here tautological implication. P conditional Q, conditional, P conditional R. So first of all, what you have to do? You have to find out the LHS value. Then you have to find out the RHS value. Then you have to take the LHS conditional RHS. Okay, so one by one see here. So PQR, so it containing three statement variables. So it will be containing 8 rows, that is 8 values will be there. So these are the combinations: true, 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 false, and false, false, false. So what is the LHS? Q conditional R. That is the sub part of the LHS, Q conditional R. You can see here. If both true, true are there, then it is a true. Fine. It is true. Okay, if it is a true, false, again it is a false, then false, true, true, false, false, it is a true, 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 it is a true, true, false, 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 true, true, false. Then false, false, again it is a true. Okay. Yes. Then next one is what? LHS, that is a P conditional, Q conditional R. So Q conditional R will become here consequence and P will be here antecedent. Okay, here will be this one is as a, this will be antecedent, and here will be what? Consequence. Okay. So P conditional, Q conditional R. So whenever both the values I am highlighting here, just wait. So you can see here, when it is a true, when it is a true, and when it is a true, then it is a true. Okay, otherwise you can see that conditional statement property you can see, and by using that, this is true, this is false, it will be false, this is true, this is true, it is true, then again true, 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 false, true, definitely true. So then false, false, here is true, again false, true, it is a true, and here false, true, it is a true. So that is the resultant. That is the resultant for what? That is the resultant for your LHS. Now you have to find out the RHS. So what is RHS? RHS is nothing but, you can see here, this one is the RHS. So in the RHS, again it containing P conditional, Q conditional, P conditional R. Yes. So what is the P conditional Q? That is the result you can solve over here. That is a P conditional Q. Then you have to find out P conditional R. And finally you have to perform this one. Simple. Okay. So true, true. It is a true. Then true, false, false. Then false, true. That is a true. Then false, false, true. Then false, true, true. Then true, true, true. Yes. Then true, true, true. True, true, true. So that is the terms over here. Yes. So that is nothing but okay. So that is nothing but your RHS. So what finally we have to do? We have to take LHS conditional RHS. So if you take LHS conditional RHS, so first value of the LHS is a true, first value of the RHS is a true, it will gives you true. And likewise, if you observe all these values with respect to the conditional statement, it gives you all the values as a true. Fine. So true, 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 true. All the values are true. Means nothing but it is a tautology. So whenever LHS conditional RHS is a tautology, that conditional will become tautologically implies. And you can read this as a LHS tautologically implies RHS. Yes. Fine. Then according to me, one question I would like to discuss over here is equivalence of statement formulas. So basically, when the given two statement formulas are equivalent, whenever LHS of the given statement formula is equals to RHS, then it is called as a equivalence of each other. So for that purpose, we are using here two methods. The method number one is called as a truth table method, and method number second is called as a formula method. So we are going to discuss here one example, one by truth table method and second one is by formula method. So let us see here. This is the example given to you. Fine. So what it contains? LHS. LHS is what? Negation of P biconditional Q. And we have to show which is same as in bracket P and negation Q or negation P and Q. Fine. So that is the example we have to show. So how many statement variables are there? So two statement variables are there, P, Q. So we have to take here P and Q. That is a P and this is a Q. Fine. So four possible values as I mentioned: true, true, false, false, true, false, true, false. So we have to find out here LHS. LHS will gives you P biconditional Q, which is nothing but you can see here true, false, 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 true, false, false, true. I am showing here. Whenever both the values are true, just wait. Whenever both the values are true, then it is a true. Fine. Whenever the first value is true, second value is false, then it is a false. Whenever first value is false, second value is true, then it is a false. Whenever both the values are false, then it is a true. That is a P biconditional Q. Then you have to find out negation of this one. So negation of this one is nothing but you can see here. Simply, if true is there, then it is a false. False is there, true, and likewise. So that is the result. So that is the result for your LHS. Now, you have to find out the RHS. So what it containing? P and negation Q. So P and negation Q or negation P and Q. So for this purpose, you have to find out here negation Q as well as negation P. So that's why I have written here negation P and negation Q. So basically P is what? True, true, false, false. So negation of this table will be false, false, true, true. And here false, true, false, true. Then on the LHS we have P and negation Q. P and negation Q is there. So simply P the first column and negation Q column. So it will gives you false, true, false, true. Then next, again we have negation P and Q, which gives you false, false, true, false, and finally by using this one and this one, you will be got here ORing of P and negation Q and negation Q and Q. This is nothing but FT, FT. So if you observe LHS and RHS, both are same. So as both are same, you can say that the given statement formula is equivalent to each other. The given statement, just wait, the given statement formula is equivalent to each other. Means LHS is equal to RHS, fine. Then this may be also solved by using this formula method. So you can see here, we have taken here, be careful about this because lots of people having problem with respect to this point. So pay the attention. So what is the LHS? LHS is simply negation of this one, negation of P biconditional Q. So now first we take P biconditional Q. So P biconditional Q having three options. So what is the options? Or having that three, what we can say, equivalences. The very first equivalence is what? P biconditional Q, which is equivalent to P conditional Q and Q conditional P. That is one possibility. Second possibility is what? This is also equivalent to P and Q or negation P and negation Q. Fine. And which is also again same as negation P or Q and negation Q or P. So all these three are equivalence formulas for biconditional. So from these given three equivalence formulas, we have to use appropriate one. We are not going to use all these three. We are going to use appropriate one. So which should be used by we people? So you can see, if you observe, we have used the third one. Now some people might be think that how that third we have chosen. It is totally logical based, so you have to practicize, and by practicing you will be getting this idea. Now if you see, the third formula is taken over here, that is negation P or Q and negation Q or P. And as we have, negation is the symbol we have taken as it is, because this is nothing but whatever we have written over here. This is the equivalence for, this is equivalence for what? P biconditional Q, not for negation of P biconditional Q. So that's why we have taken negation over here. Fine. So that is the equation number 1. Now, what we have to do? Now apply De Morgan's law on equation number 1. What we have to do? We have to apply De Morgan's law on equation number 1. So what will be the De Morgan's law? Okay. So this negation we have to take inside. So if you take here, this negation is came to inside. This term is as it is, remain as it is. You can see this term is as it is. We have taken this negation over here. Then previously it was ending. It is replaced by ORing, and this negation is taken over here, and this term as it is. Okay, so that is the equation number 2. Okay. Then again apply De Morgan's on equation number 2. Again we are applying De Morgan's law on the equation number 2. What we are going to do here? On this equation, whatever highlighted by that yellow color, you can see here. This negation of negation P will become P. This OR will become here and this negation will be used to this Q. Okay. Again, this OR will be as it is, no issue. Then negation of negation Q or P. You can see here. Negation of negation Q, that is a Q. This OR will become here and this negation is given to this P, it will become negation P. That is the equation number 3. Now check whether the RHS is same as this one. No, little bit difference is there. So for that purpose we are applying here commutative law. So not necessary to apply commutative law on the first half part. It will be remain as it is, that is P and negation Q. This OR will be as it is, but we are interchanging this Q and negation P. So for that purpose, we are applying here commutative law. So we have interchanged this negation P over here and is as it is and Q over here. So that is the equation number 4. So from the equation number 4 and LHS, so if you see equation number 4 and LHS, okay, equation number 4 and LHS both are same. So that's why the given statement formula is equivalent formula. Fine. So this is the method for finding equivalence by truth table. This is by equivalence by statement formula. Again, one more example I am giving with respect to the three statement variables P, Q, R. So by the table method, you can see here the given. Okay. So LHS is R. Okay, LHS is R. And on the RHS, this is given. Now, given statement formula containing three statement variables, that is P, Q, R. Hence, truth table will containing three statements. Basically, it will containing first three statements P, Q, R. And number of rows will be 2 raised to 3, that is equals to 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, by using this, you have to check RHS because we have given LHS with a single statement variable. Not possible to derive this term from the single variable. So for that purpose, we are going to take here RHS. So what actually we are going to do? See here. So negation P, you can see here negation of P and negation Q and R. This bracket is completed. Or in bracket Q and R bracket complete or P and R. That is the given statement formula. So PQR negation P will be derived from this formula. Negation Q will be derived from this Q. Now negation Q and R. So negation Q and R, it will use this result. Then you can see here, this is the term, whatever I have underlined, that is the term. I have mentioned this as A. Then I have mentioned Q and R by B. Then P and R by C. And I have tried to simplify. So if you see here, this A is nothing but this negation P and in bracket negation Q and R. It gives you false, 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 false. Then second last true and last one is false. Then B is nothing but derived from this formula Q and R. C is nothing but derived from this formula P and R. And finally A or B is nothing but D. We have taken this A and B together, which is nothing but D. And we have taken this C and D, this one and this one together, C and D, to got this result. Fine, we got this result. So if you observe, C or D is nothing but RHS. And if you observe that RHS, simply you can see which is same as the resultant of, you can see here, true, false, true, false, true, false, true, false, which is same as R. So hence, column R and the resultant column are identical. That's why you can say that this one is equivalence. Okay, so that is the one example. That these are the two examples I would like to discuss over here. The next point I am going to discussing here what is meant by tautology and what is meant by contradiction, and one example. Then I'll be wind up the chapter number 1 according to my opinion. These are the important points. So, what is meant by tautology? Whenever we are finding a truth table for the given statement formula, all the resultant values are true, then it is called as a tautology. It is also called as a universally valid form, or it is also called as a logical truth, or it is called as a identically true value. That is called as a tautology. Now you can see this table which containing the tautology. P and P is given to you. And you have to find out negation P. Yes, it is possible. Then P or negation P. If you find here P or negation P, then it gives you both the truth values as a true. That's why it is called as a tautology. This one is your tautology. Then what is a contradiction? In the case of contradiction, when resultant column is a false, then it is called as a contradiction. Fine. Resultant column is false, then it is called as a contradiction. And what is about contingency? So contingency, it is the condition which does not have tautology or a contradiction. then it is called as a contingency. Now see one example here. One example I have discussed here. So the very first example, P conditional in bracket Q, P or Q, bracket complete, fine. So as containing two statement variables P and Q, it will give you 4 rows, 1, 2, 3, 4. So we are going to take here PQ. These are the truth values: true, true, false, false, true, false, true, false. P or Q. So P or Q in bracket we have given. So that's why true, 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 false. Okay. And then we have find out P conditional, P or Q, which gives you all the resultant values as a true. That's why the given problem is a tautology. Then one more we have taken for the this solving purpose. So if you see here again PQ, these are the two statements, this P and Q. So you can see here true, true, false, false, true, false, false, true, true, false, false, true, false, true, false. Then negation Q is this one, and we have see here negation Q and P. You can see here, and finally resultant column is nothing but false. That's why it is called as a contradiction. So that's all for the chapter number 1. According to me, these are the important points. So what we have discussed, the very first point is nothing but the preposition, or it is called as a statement, or it is also called as a declarative sentence. Okay, you have to keep in mind that. Then types of statement, basically it having two types. First one is the unary and second one is the binary. In the case of unary we have negation, in the case of binary we have conjunction, disjunction, conditional and biconditional. Then we have see what is meant by well-founded formula. Well-founded formula which having 4 rules. Alone statement formula is a well-founded formula. Negation of the original statement formula. Then third one, P and Q are the two statement formulas. Then we having P and Q, P or Q, P conditional Q and P biconditional Q. These are the well-founded formulas. And the last one, combination of all these together is also called as a well-founded formulas. Then we have seen what is meant by duality law. In the case of duality law, for example, one statement formula is given to you, then dual of that statement formula, which is find by replacing conjunction by disjunction, okay, disjunction by conjunction, then negation will be as it is, truth value true by false, truth value false by true. So that is nothing but the duality law. Then what is meant by tautological implication? So already we have discussed that formula, discussed that 3 examples. Very important examples are there. Then what is meant by equivalence? In the case of equivalence, we have seen 2 methods. First one is the table method, and the second one is the formula method. Keep in mind that whatever asked in the examination, you have to go accordingly. And the last one is what is meant by tautology, what is meant by contradiction, and what is meant by contingency. So guys, that's all for the first chapter. These are very important questions according to me. Keep in mind, according to me, because it contains only 50% points out of that syllabus. All these points we have discussed in the class lecture, but as per the demand from the students, I am giving here important questions. Thank you so much for your patience listening. Okay, so you can go through it, and if any query, you can free to ask me. Thank you so much.